Hello, students. I am Madhuri, your maths teacher. I will teach you 9th standard maths, CBSE syllabus. First lesson is number system. Part 1 is over. That was between any two given rational numbers, there lie infinitely many rational numbers. Today, part 2. So today we will learn about real numbers. Real numbers include rational and irrational numbers. And today we will learn terminating decimals, terminating repeating decimals, and non-terminating, non-repeating decimals. This is part 2, exercise 1.2 and 1.3, questions 7, 8 and 9 we will solve today. What are irrational numbers? A number which cannot be expressed in the form p by q, where p and q are integers and q not equal to 0 is called an irrational number. Cannot be. A number which cannot be expressed in the form p by q. A number which cannot be expressed in the form p by q, where p and q are integers and q not equal to 0 are irrational numbers. What is rational numbers? A number which can be expressed in the form p by q are rational numbers. Which cannot be expressed in the form p by q are irrational numbers. Example for irrational numbers: root 2, root 3, root 5, pi, 0.10, 110, 1110, 11110, etc. are examples for irrational numbers. Every real number is either a rational number or an irrational number. So every real number is either a rational or an irrational number. So real numbers are combination of rational numbers and irrational numbers. Rational numbers includes natural numbers, whole numbers, integers, fractions and fraction with the negative signs. Now again rational numbers and irrational numbers. So we will learn about terminating decimals, non-terminating, repeating decimal, non-terminating, non-repeating decimal. So what is terminating decimal? Terminate means to end or stop. So here 1 by 8. The answer is 0.125. So completely we solved. Nothing is remaining. So it stopped here. 1 by 2, 0.5. 1 by 4, 0.25. So it stops, end or stops. But here 2 by 3, there is no end. 2 by 3 is equal to 0.6666, etc. That means 0.6 bar. So repeating decimals go on forever. Repeating decimal means it go on forever. There is no stop. It go on forever. 3 by 11, 0.272727, etc. That means 27 is repeating. 27 go on forever. 11 by 6, 1.83333, etc. 1 and 8 are not repeating, but 3 is repeating. So this is repeating decimal, non-terminating, no stop, and repeating decimal. So non-terminating, repeating decimal and terminating decimals are rational numbers. Both are rational numbers. Now non-terminating, non-repeating. So there is no stop and no repeat also. Example root 2. 1.4142135623733095, etc. So there is no stop and no repetition. Root 3 also same like that. 1.7320508075688877. So there is no stop and no repeating. Pi is also non-terminating, non-repeating. So non-terminating, non-repeating decimals are irrational numbers. So terminating decimals and non-terminating repeating decimals are rational numbers. But non-terminating, non-repeating decimals are irrational numbers. Now we will solve exercise 1.2. State whether the following statements are true or false. Justify your answers. Every irrational number is a real number. Every irrational number is a real number. So we learned that real number are the combination of rational and irrational number. So every irrational number is a real number is a true statement. Answer is true, since the collection of real numbers is made up of rational numbers and irrational numbers. So every irrational number is a real number is a true statement. Second, every point on the number line is of the form root m, where m is a natural number. Is it true? Every point on the number line is of the form root m. So here root 4 is equal to 2. It is on the number line. But every number, what about negative numbers? False, because no negative number can be the square root of any natural number. No negative number can be the square root of any natural number. Positive 4, square root of positive 4 is 2. What is the square root of negative 4? No. There is no negative number can be the square root of any natural number. Now next one, every real number is an irrational number. Here we learned that every irrational number is a real number. But every real number is an irrational number. Is it true? Real numbers include irrational numbers and rational numbers. So every real number is not a rational number. Rational numbers also. False. For example, 2 is a real number but not an irrational number. Are the square root of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. Square root of all positive integers irrational. So what about root 100? Root 100 is 10. It is a rational number. So every square root of all positive integers is irrational is false. For example, root 4 is 2 is a rational number. Now show how can we represent root 3 on the number line, or representation of root 2, root 3, root 5, etc. on the number line. This I will give a separate class for this one. This I cannot do in the PowerPoint. So I will do a separate video for representation of root 2, root 3, root 5 on the number line. Exercise 1.3. Write 3 numbers whose decimal expansions are non-terminating, non-repeating. Non-recurring means non-repeating. That means write 3 irrational numbers. So here non-repeating and non-terminating, no stop and no repeat. 0.01, 001, 0001, 0001, 00001. 0.20, 200, 200, 2 zeros. Then 0.003, 0003, 00003, etc. So these 3 are examples of irrational numbers. That means examples of non-terminating, non-repeating, non-recurring decimals. Find 3 different irrational numbers between the rational numbers 5 by 7 and 9 by 11. Solution. 5 by 7. So how we will divide 5 by 7? 5 is equal to 5.00. We can write many zeros. Okay. So here 5 by 7. How many times 7 in 5? 0 time. And after that, remainder 5. Next is point. I will put the point on the quotient. Then we will take 1 0 down. Now 5 and 0 together for 50. How many times 7 in 50? 7. 7s are 49. Remainder 1. Now again 1 0 down, 10. How many times 7 in 10? 1 time. 1 times 7. Remainder 3. Again 1 0. 30. How many times 7? 4 times. 7 fours are 28. Remainder 2. Again 1 0 down. 20. How many 7s in 20? 2 sevens. 2 times 14. Remainder 6 60. How many times 7? 8 times. 8 sevens are 56. Remainder 4. Now 40. How many times? 7. 5 times 7. 5 sevens are 35. Remainder 5. See, again we will start from here. This process will repeat. That means 0.714285, again 714285, again 714285. This will repeat. Now 9 by 11. So 9 point, you can write many zeros after decimal point. So first 9, how many times 11? 0 times. So now remainder 9, next is decimal point. In the quotient also you need to put decimal point. After that 1 0, together 9 and 0, together form 90. 11, how many times 90? 8 times. 88. 11 eights are 88. Remainder to 20. Now how many times 11 in 20? One time 11. Again 9. So see, we will start from this. This process will repeat. That means 81 will repeat. So 0.818181. So 5 by 7, the decimal form of 5 by 7 is equal to 0.714285, etc. And 9 by 11 is 0.81 bar. So now we want to find three different rational numbers. So 5 by 7, the decimal form of 5 by 7 and 9 by 11 we found. Now you have to find three different rational numbers between these two. So take the first two decimal places, 7 1, here 8 1. So write two rational numbers between 0.71 and 81. The different rational numbers between the rational numbers 5 by 7 and 9 by 11 are between 0.71 and 81. 0.75 will come between. When will come? So I choose 0.75. So 0.750, 7500, 7500, etc. are one rational number between these two. Second one, 0.7530, 75300, 75300, etc. Again one more. 80 will come between 0.719 and 0.81. So 0.80, 880, 880, etc. is another rational number between these two. So these are the three different irrational numbers between 5 by 7 and 9 by 11. Exercise 1.3. Classify the following numbers as rational or irrational. So here root 23, root 225, 0.3796, 7.478478, 0. That means 7.478478, then 1.10, 100, 100, 100, 100, 1, etc. So I will make a column like this. All the numbers I wrote here, and in decimal representation also I wrote here. So what is the decimal representation of root 23? 4.79583152, etc. So this is a repeating decimal, non-terminating, non-recurring, non-repeating, non-recurring. This is not a repeating decimal. This is a non-terminating, non-recurring decimal. So it is an irrational number. Here root 225 is 15. So 15 by 1. It is a rational number. 15 by 1 is a terminating decimal. So it is a rational number. Then 0.3796. 3796 you can write as 3796 divided by, here 4 decimal places. So I will write 1 followed by 4 zeros. That means 10,000. 3796 divided by 10,000 is the decimal representation. This P by Q form of 0. 3796. So it is a terminating decimal. So it is a rational number. So here then nothing is repeating. So it terminates. Here 7.478478. That means 478 is repeating. So it is a repeating decimal. Non-terminating, repeating decimal. Non-terminating, recurring decimal. Recurring and repeating are same. So here this is a rational number. Non-terminating, repeating decimals are rational numbers. Next one, 1.10, 100, 100, 140, etc. It's a non-terminating, non-recurring, non-repeating decimal. It is an irrational number. Okay, so classify the following numbers as rational and irrational. This is a rational number. So, the decimal expansion of a rational number is either terminating or non-terminating repeating, non-terminating recurring decimal. Decimal expansion of a rational number is either terminating or non-terminating recurring. The decimal expansion of an irrational number is non-terminating, non-recurring, non-repeating. So the decimal expansion of a rational number is either terminating or non-terminating, repeating or recurring. The decimal expansion of an irrational number is non-terminating, non-recurring. Now next lesson will be, so this I will teach in the next class. Real numbers and their decimal expansion will be the next class. Up to that, you learn today's class, understand well, learn well and practice well. Okay children, bye now.